Hello, and welcome to Lecture 10. In this lecture, we're finally going to make something useful. Namely, this is what we're going to make today. When you type in the name of the picture, it will show up. For those of you that have never been to Spain, let me give you a little show and tell. Particularly, this is the city I used to live, Madrid. Here's the picture of the Royal Palace. Just to give you an idea of how large the palace is, I'm about 6 feet tall. Those statues you see are probably 3 to 2 times my height. This is the Egyptian temple right in the city. It was a gift from Egypt a long time ago. It's kind of odd to see this while in the middle of Madrid, because you see these big buildings and all of a sudden you see the Nile River. And this is the sunset of Madrid, taken from a very tall building. A bunch of friends and I, we snuck up the building to take this picture. We were caught and almost arrested, but we got the picture. This is a picture of Rebecca and me when we snuck up the building to take the previous picture. This is the most precious picture I have. It was taken on a street called Gran Via. This is basically the Times Square of Spain. You can't see much from this picture since the resolution is really low. From the original picture with very high resolution, you'll see people in every single window looking at this fountain at this particular moment. We probably had over 10 different people taking this picture and recording the scene. I can't tell you what's in the picture, but maybe you can figure it out. So now that you know what this program does, we're going to learn how to make it. In the future, we'll be adding more to this program to maybe add like a short story on the side. We can make it more user-friendly as well. But for now, this program is pretty cool to start. Since this is a large project, I'm going to divide it into 2 lectures. In this particular lecture, I'm going to go over the important concepts that we're going to need to program this. There are 2 main themes I want to talk about. First, we must talk about variables. What are they? What they can be. Next, we will learn the concept of global and local variables. They determine where your variables are known to the program. These 2 concepts are extremely important in creating the application. In general, if you have ever had any programming experience, they will always talk about variables and global and local domain. If you have taken that before, this class will be extremely easy. If you haven't, you should pay attention because this is pretty important stuff. So, let's first get started with the concept of variables. What are they? Well, you can see them as the names of a container. When you assign a value to a variable, for example, a statement like number equals to 5, what you're really doing is putting the number 5 into the container. So in the future, when people ask you about number, you will look at the container and say that it contains number 5. The most common way we use the variable is by printing them out. For example, we will use the statement print number. This statement is exactly the same as print 5. There are 2 types of numbers we print out, integers and floats. Integers are whole numbers, 1, 2, 3, 4, 5, 6, 7, 8. The floats can be anything else, 2.3, 1 over 2, 4 over 5, 45.32. The reason why this is important is because when you divide integers with integers, you get integers. For example, if you take 1 and divide it by 9, 1 over 9, notice how it prints out 0? Well, this is obviously wrong. The reason why it prints out 0 is because the actual number is 0.11111111. But since the answer must be an integer and a whole number, the decimals are automatically cut out. To solve this problem, you want to make one of the number a float value. By doing so, your answer will also be a float. Let's make the number 9 into 9.0. Notice how now it's putting out 0.11111. You want to make sure you pay close attention to this detail. You will be spending a lot of hours trying to figure out what is wrong with your program, when all you have to do is add a 0.0 at the end of a number. Besides numbers, this container can also be used for many other types of objects. You can put words in them. You can put sentences in them. The way you differentiate between numbers and words is by adding quotes around the words. For example, you can treat 5 as a word or as a number. If you write number equals to 5, 5 in this case is a word. If you try to add a number to it, it will confuse the computer. You cannot do addition and subtraction with words. However, if you use a statement such as number equals to 5, now you know that number is a 5. So if you create another number called number 2 equals to 9, and you print out number plus number 2, you'll get 14. With words or sentences, the proper name for them is a string. With strings, you can use either single quotes or double quotes. Normally, a single quote is good enough. However, sometimes a single quote might be in your sentence. For example, for the sentence, I don't want to smell your sock. There's a single quote right inside the sentence at don't. To enclose the sentence like this one, we will need to use a double quote so the interpreter doesn't get confused. Now that we have gone over 3 types of variables, integers, floats, and strings, there is one more type. They are called booleans. Booleans are the most simple type we have. You put either true or false into the container. The way you assign a boolean is by capital T, R-U-E, or capital F, false. We have already used boolean in the if statement in the past. Basically, you use them to check conditions that are happening. If it is true, then you do something. If it is not true, you do something else. So together, we have 4 types of objects we can put into a variable container. Integers that follows a statement like this. Number equals to 5. Floats that follows a statement like this. FL equals 4.3. And strings that has a statement like this. Sentence equals you have smelly boots. And booleans with a statement like B equals to false. Sometimes in your program, you might want to check what type of a variable you have. This could be done easily with a command type. For example, if I write type number, in the past, our number is a number 5, and when it returns, it says int, meaning that it's an integer. If we try type num, it will return that it's a float. Basically, if you put the variable between the parentheses, it will tell you what type the variable you've got. Now that we understand what variables are, the next question we want to answer is where do they go and where are they recognized? Let's see. If I start talking about this girl named Jennifer, chances are you know a girl named Jennifer also. But we probably are not talking about the same Jennifer. The Jennifer that you know or I know are called local names. They are local because not everybody knows about them. Or I can start talking about George Washington, Einstein, Picasso, Tom Cruise, Britney Spears, Paris Hilton. Now we're probably talking about the same people. These names are called global names. They are global because everybody in the globe knows about them. With programming, we have the same situation. You might have a couple functions talking to each other. How do we know if we are talking about the same variable? After all, variables are also names. We use the same idea with local and global variables. Let me give you a quick example. This is a program with two parts, a function and a main program. If you look at the main program, it will call the function God. God makes Jennifer equals to pretty. After you finish the function, it goes back to the main program and try to print out what Jennifer is. You might think that the program will print out pretty, but this is not the case. The program will crash because the main section doesn't know who Jennifer is. You see, if you look at the program, Jennifer was first introduced inside the function God. This makes Jennifer a local variable, which means that only God knows who Jennifer is. The main program has no clue, so when you tell the main program to print out Jennifer, it gets confused. In order for the main program to know who Jennifer is, the function must specify that they are talking about global Jennifer. To do so, inside the function before Jennifer was introduced, you want to write global Jennifer. Easy enough. This says that you're talking about the Jennifer that everybody knows. So if I run the program now, the main program will recognize Jennifer and print out pretty. Let's run it. You see how now the main program recognizes Jennifer as pretty, all because God said so. There's a catch too with this global and local variable. You see, only things that are created inside the functions are local. If things are created inside the main program instead, it is automatically global. You can kind of see the main program as Hollywood. Everything created from Hollywood is automatically famous. Everything else created somewhere else, well, you don't really know it. So if I go back to the code and switch the sequence, I will create Jennifer first and make her beautiful inside the main program. I will then print out Jennifer in the function without declaring global. You will see that when we run the program, it will still print out perfectly fine because Jennifer is global variable now. So let's run the program now. From this, you see that you must be very careful with the variable. If you create it inside a function, you got to make sure that it becomes global if you have to use it later. But if you create it inside the main program, then it's automatically global. The thing is, when you get out of the function, nobody knows who Jennifer is. As a matter of fact, even the function itself forgets who Jennifer is. So when you run the function again and ask the function, who's Jennifer, they will tell you that they forgot. At this point, you might be thinking, why don't we just make everything a global variable? And I agree with you. It's much easier to program with lots of global variables. But it is actually bad programming habit. This is because the computer uses up more memory for global variables. You might only need to use the name once and never goes and use it again. That's kind of wasting the memory. But the decision is yours. Using global variables makes programming easier, but it will slow down your programs. I guess it's all a trade-off. Okay, today we started with looking at the programs we're going to create next lecture. I gave you a little show and tell on the city of Madrid. Then we looked at basic 4 types of variables: integers, floats, strings, and booleans. They're like objects that we can put into the variable container. In the next lecture, in order for us to program the application, we will need to use some global variables. So make sure you understand this concept before you move on to the next lecture. For your homework, I want you to go back and review the concepts of global and local variables and how we can declare them and how we can use them. And that will be all for now. This is Chieh. Until next time.